The intricate reactions that sustain life never cease. Driven by his insatiable curiosity in those processes, neither does Alexander Rich. For more than 50 years, he has worked tirelessly to unlock many of the mysteries surrounding RNA and DNA. In the process, he has begun to unravel some of the secrets of life itself. Some of his earliest insights into nucleic acids, made decades ago, remain relevant today as scientists explore the possibilities they hold for preventing and treating disease.
Indeed, I consider him amongst the pantheon of 20th century scientists who've used the power of chemical science in order to begin to understand the molecular basis of life.
For his outstanding contributions to the understanding of the chemical and biochemical mechanisms in maintaining a living cell, the Welch Foundation honors Alexander Rich with the 2008 Welch Award in Chemistry. Named after Houston oil man and philanthropist Robert Alonzo Welch, this award recognizes chemists whose dedication to basic research contributes to the betterment of humankind. Tonight we honor a man who has greatly advanced scientific knowledge of how the machinery of life works. His bold insights into the structure and function of nucleic acids have provided a basis for many modern-day disciplines.
Alex never stops. And he's constantly thinking, imagining, moving, with the flow, when things develop, that he always has ideas.
All people are mortal, but Alex seems to have figured out how to become a little bit immortal, and at least through his science, quite a bit immortal.
Dr. Rich grew up in Springfield, Massachusetts, the son of a dry cleaner and homemaker. His father, who had limited schooling, imparted a reverence for education to Alex and his older brother David. With a deep respect for learning and his intense curiosity, Alex began his scientific journey with playmates when he was only 8.
Then I would also tell them about the mysteries of life. I said, well, what's beyond the beyond? I mean, what's on the outside? You can see as far as you can see, but what's beyond that?
After graduation from high school, Dr. Rich was awarded a scholarship to Harvard University, where he enlisted in the Naval Officer Training Program. He earned both his bachelor's and medical degrees from Harvard and conducted his postdoctoral work at the California Institute of Technology under renowned scientist Linus Pauling. He later joined the National Institutes of Health before taking a position in the biology department at the Massachusetts Institute of Technology, where he has taught for 50 years. Dr. Rich is as intensely active outside the laboratory as he has been within it. His deep concern about the threat of nuclear war in the 1950s led him to participate in pugwash meetings to discuss new ideas to reduce tension between the East and West.
It started by my having a son and trying to teach him to be careful about going across the street. But at that time, I realized that an even greater hazard to his health was the possibility of a nuclear war.
He has helped guide the machinery of science by serving on numerous boards, including the National Science Board. And his contributions have been recognized with prestigious awards, including the National Medal of Science. Among Dr. Rich's first notable discoveries was his identification of the three-dimensional structure of collagen, a major fibrous component of the skin, with Francis Crick, who helped decipher the structure of DNA.
The problem turned out much simpler than we imagined. And we, within a short time, 3 hours, we had a structure that predicted the diffraction pattern.
Deciphered without the sophisticated technology used today, the collagen structure they proposed was confirmed using high-speed computers and modern techniques 40 years later. When Dr. Rich began his focus on ribonucleic acids, known as RNA, very little was known of their form or function. His discovery of RNA's double helix changed that, but not everyone immediately realized its importance.
I think Alex has changed the notion of how important RNA could be. In 1961, he postulated RNA could involve genetic regulation and development. And he even laid out a scheme how it could be done. And that scheme, 45 years later, become reality. So that shows his thinking so ahead of everybody else.
His continued work in this area led to the first DNA-RNA hybridization. This discovery provided the first glimmer of understanding of how information is transferred from DNA to RNA, and was later used to develop a Nobel Prize-winning technique that is widely used today.
Alex's fundamental contributions here have really helped to lay the basis of our understanding how information is transferred from DNA to RNA to protein, and that is in fact considered to be the central dogma of molecular biology.
Dr. Rich also discovered DNA's left-handed helix, called zDNA. While it provided a missing link in DNA's structure, what the discovery solved was not immediately apparent.
And it took quite a while to learn enough about its properties to realize that it could form in biological systems. And finally, with the proteins, you began to get an understanding of its function.
Currently, Dr. Rich is researching the biological role of zDNA and the proteins that bind to it. He and his colleagues have pioneered this field of science and revealed a novel mechanism important to viral diseases such as smallpox. In the classroom and around campus, Dr. Rich is passionate about sharing the thrill of discovery with others and exchanging good ideas.
I like contact with young people because they often ask questions that you may not have thought about, or they may see things a little differently.
He's not someone you meet as you walk by. He's interested in talking to you, and you're interested in talking to him because in those conversations, you almost always learn something new.
Those who want to discuss science with him know that they will have to wait until afternoon or later to find him, given his aversion to morning.
But the wait is really worth it, because when you get together with Alex, the conversations are just so animated, so exciting, so interesting. It's just a real pleasure to get together with him.
When he's not in the lab, Dr. Rich enjoys reading and spending time with his wife, Jane. The two were married in 1952. His adventurous spirit and optimistic determination were immediately apparent to Jane.
I knew that he was somebody who was going to be doing things that were interesting and exciting, and I wanted to find somebody who was doing something that they wanted to do.
Jane and Alex have 2 sons and 2 daughters, 3 of whom pursued an education in science.
I never tried to push them. I think they could see that I was enjoying myself, and so they sort of worked in the same direction.
Even at home, Dr. Rich's interest in the origins of life is apparent.
I always have a curiosity about ancient life, and I feel very much connected if I have a fossil in my hand.
For Jane, whether they're playing with their grandchildren, reading, traveling, or collecting fossils, time spent with Alex is always good.
I admire his determined, cheerful outlook. Even when things are not good, he finds something to feel good about. He looks for the crack in the trouble, and I like that.
With his penchant for problem solving and a half-century of hard-found solutions already under his belt, it appears Dr. Rich may just be getting started.
What is exciting about science is the excitement associated with a discovery. You see something new. And I must say, when somebody else makes a discovery and I read about it, I get that same boost of awe and wonder about nature.
His fundamental insights continue to shape many areas of research and have infiltrated our daily lives.
Alex's insights really have and continue to have a profound effect now on human health and indeed on the economy.
Alex's work is so fundamental that as long as human beings are taught biological science, Alex will have left a monument in the culture of humans.
For his dedication to biochemistry, his fundamental discoveries in nucleic acids, and broad contributions that have given birth to new fields of science, we honor Alexander Rich, the 2008 recipient of the Welch Award in Chemistry.